I want to talk about solving kinematics problems and exercises. Again, some of the least interesting stuff we talk about, but it's part of this content. These are questions related to the graphing we've done, but the graphing that we've been doing is supposed to be a way for you to connect what happens in the real world with some kind of visual representation of that. All of you people who claim to be visual learners are supposed to be super good at graphs. So I think that maybe we say visual learners means actually just show me something. But visual learners are supposed to be able to easily articulate something that they see in the real world with something that is a tactile representation of that or a visual representation of that. So, I tried to cater to all those people who in their survey said that they're a visual learner. You can't get more visual than having the prop in front of you, a picture on the board, and then the graph that represent it, and a way for you or means for you to take data that actually replicates what I'm asking you to produce on a pictorial graph. So I want to be very clear. I gave you the means to try out every single possible graph with the car and a motion sensor. If you chose to make that a activity that you just got through instead of something that helped you understand why the graphs look the way they do, that's on you. But that's why, and you'll notice I've left the tracks out. We haven't used them in a week. But they're out because if you need a visual representation, grab a meter, put it on the track, and push the car. Right? Do the quiz. That's why they're there, for all those people who want that visual learning experience. So I gave you the opportunity for the graph on purpose so we could connect it to this stuff. But now I want to step away from that. I don't really want to talk about graphs. I want to talk about how we can use the information we derive from the graphs to solve kinematics problems. I'm going to give you an example of a kinematics problem. You may wish to write this down. I'm going to do 4 examples, 2 examples today. So here's question number 1. And I'll make it relatively straightforward. A car accelerates to 40 meters per second from some initial velocity. It does so in 2 seconds over a distance of 50 meters. How fast was it going? A car accelerates from some initial velocity to 40 meters per second in 2 seconds over a distance of 50 meters. How fast was it going? While we're at it, what acceleration did it experience? Here's where you will screw up your notes. So I'm right now speaking to the people who don't take good notes. Like when I started saying the problem, waited until I made it to the 3rd time to actually start writing the first word down. You have a problem. I'm not handing you my notes. You need to be faster. You need to be understanding what's important. So here's where the notes actually begin. I don't want to do graphs anymore. I want you to solve these problems using what we derived from graphs. We will make an assumption that this car experiences uniform accelerated motion. If that is true, all 5 of those motion variables and all 5 of those motion equations are useful in figuring out what's missing. If you wish to solve an exercise like this, and I call this an exercise because it's a one-step plug-and-chug problem. It's not a problem, and it's not at the level I want you working at, but it's a good place for us to start. It's an exercise. Exercises are easy. To solve an exercise like this, start by listing the motion variables. That is step 1. Once you're proficient at this, I really don't care how you do it. but on your first quiz on this stuff, I'm going to look to see if you identified the appropriate motion variables. I'll be looking for this list, and to see if you were able to take the information from the problem and place it appropriately where it goes. This part shouldn't be hard, because as a small aside, they're going to be labeled with their units, so you should be able to figure out which number goes where. Except perhaps in one case where there's two variables that match the same unit. You shouldn't make a mistake here, but you will. I will watch you do it, but you shouldn't make a mistake here. In this problem, I have 50 meters is the displacement of the vehicle. I don't know where it starts, but I know where it ends at 40 meters per second, and I'm told it takes 2 seconds. I've identified the information provided in the problem. Another aside, useful for your notes, is it takes 3 pieces of information to solve one of these problems. Every equation has 4 variables in it, so you need 3. If you don't have 3, there must be something else in the problem that's not clear, and you need to figure out what it is. That usually makes it a problem and not an exercise. But an exercise will give you clearly 3 pieces of information. Now your job is to find what's remaining. And the first question wants us to find the initial velocity. So, in order to find the initial velocity, cross out the variable that you don't have and that you don't need. We don't have the acceleration, and we don't need to find it initially. So I'm crossing it out. Now, this is a step, and I'm trying to give you a procedure that anybody can follow. So here's the procedure. After you've crossed that out, if you have a note card that's organized the way my note card is, then whatever variable you crossed out, that's the relationship that will solve your problem. Because that relationship will have everything in it you need to solve the problem. So I crossed out the acceleration, which meant it should be the relationship without acceleration that I use to figure out the answer. So step 1, list your motion variables. Step 2, make sure you have 3. Step 3, cross out the one you don't need and don't have. And step 4, use that relationship to solve your problem. Now, to be quite frank, plugging in the numbers is the least interesting part of this, and the part that I really, really don't care about. I believe you should be proficient at it, but I really don't want to spend a lot of time on it. Okay? I want you to have a way to get to the answer, but I'm really indifferent about the number part. In all of this, going from here to here, 1 point. When I grade this though, generally there's 2 to 3 points for correctly getting the right information from the problem, 1 point for identifying the appropriate relationship that would be used to solve that problem, and 1 point for doing the arithmetic. If I'm gonna give 5 points for this activity, 4 of those 5 points are about the process of gleaning the appropriate information, and only 1 point for doing the arithmetic. So please understand, I don't care about the arithmetic. If you suck at math, you're gonna lose a point on these problems. But you should be able to get all the other points. Fair enough? All right. I'm going to assume you guys can find the acceleration. So I'm gonna leave this problem, try a different one. I wanna give you a couple of exercises because I'm gonna give you about 15 to 20 of these anyways. They don't go particularly long. So question number 2. Here's another exercise. Again, they're all the same to me. I can just provide you 3 pieces of information and you should be able to figure out the other 2. As long as I choose appropriate values, it should be pretty straightforward. If you want examples that are messier, use your book because they'll have ones that have numbers like 5.7 and 2.3. But I generally just don't care about the numbers that much. So the ball rolls down a ramp, it accelerates at 1.5 meters per second squared over a distance of 10 meters, starting from rest. How fast is it going at the end of the interval? And how long did it take to do this? Again, this is an exercise, meaning it should be able to be solved in 1 or 2 steps. If done correctly, a single relationship should solve this exercise. This is not a problem. This is just a plug and chug. So I'm going to start by identifying the variables that are given. Using the units and their description, I think we can place these where they go. Why don't you give it a try? I know we're on modified schedule today, so I have to be cognizant of time. I have 2 minutes. So you write them where they go. I'll tell you if you're right or wrong. That should be where they go. You should have nothing for final velocity and nothing for time. Now, you need to choose appropriate relationships that will help you solve your problem. If you want the final velocity, then ignore the time and choose the relationship that is located next to time. It should solve your problem in a single step. Now, V final is the square root of 30. Be careful here. I'm trying to give you notes, but you guys just write down what I write on the board, and that is the absolute worst thing you can be doing. So I'm stopping everybody to tell them something important. You already learned this, but you have forgotten. When you take the square root, it's always plus or minus the square root. Be aware that this relationship can't tell you direction. You have to infer direction from the answer. That's important because we're going to become more particular, especially when we transition from exercises to problems. Exercises are easy. Don't become overconfident with this stuff. This stuff is intended to be easy. Your homework is in 2 parts. Anything marked with free fall, we can't talk about till tomorrow. But they start out easy and are marked exercises, and then the last couple are marked problems. Start wherever you wish. The exercises are like these, and practice this evening. There won't be a quiz tomorrow, but practice this evening, please.